This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seberg, I'm your host. Today I'm going to be talking to James Zhang, if I pronounce that correctly. We'll hear that in a moment. He's the co-founder and CPO of OpsMate AI. And James and I are going to be talking about implementing AI agents in factories. Hi, James.
Hey, Peter. Thank you for having me.
You're very welcome. Did I pronounce your family name correctly, actually, or?
Well, I would say you pronounce it better than 99% of the people who speak non-Chinese.
Okay, very good. Please introduce yourself to our listeners, James.
Sure. Hello, everyone. Thank you, Peter, for having me again. My name is James Zhang. I'm the co-founder and the chief product officer of OpsMate. OpsMate, we are an early stage startup. We build industrial knowledge agent platform focused on factory operations, and our headquarters is in Boston, US.
Okay. Yeah, as I typically do when testing the quality of the signal, I asked you how the weather was, and you said the weather is, and it turned out to be very similar to where I am. It's snowing at the place where you are. James, together with Amol, and it's another not so easy family name, Atgao Ankar, I believe, Senior Director of Manufacturing and Supply Chain, Microsoft. You wrote a practical guide for IT and OT professionals to implement AI agents in factories. What is that about? A first introduction, please.
Well, let me talk about why we wrote that article. As you know, AI, agentic AI, generative AI is everywhere now. And in the past 2 years, we say this starting from marketing hype into some early adoptions. But meanwhile, as you know, this generative AI, agentic AI is completely new technology. I would say a platform. It's kind of like the whole technology architect is very different. And we just felt, hey, it's really critical a topic for the industry. And OpsMate and alongside with Microsoft, we have been learning some license together. We feel this just necessary to share with a broader community. So because it's early stage, so we share our lessons learned, and we can all learn from each other and grow from there. That's pretty much the purpose.
Okay, that's a good introduction. Let me go one step back. Tell us a little bit more. You said OpsMate is a startup. You want to tell a little bit more about what OpsMate AI Incorporated exactly is?
OpsMate, well, if you look at the name of the company, operations teammates. What we believe is that with today's technology, especially generative AI and agentic AI, we can bring in some digital workforce into the factories. The future of the factory will be run by a hybrid workforce. There can be the human team, there can be the robots, and then there will be a digital workforce. This is the agent will do the knowledge work together and alongside with human team. And OpsMate AI, our product is, I would say, is one of the first industrial knowledge agent platform. We purpose built it to bring in this digital knowledge worker into the factory floor.
Okay, so why then do factories now need AI agents?
There are multiple reasons. One is that, I mean, this productivity plateau. If you think about in the past decades, and especially the past 10, 15 years, you know that this we put a lot of money investment into all these technologies, data platform, Industry 4.0. But in US, one example, the productivity is not even growing, it's declined by 4.4%. That is one thing. And then you have to ask yourself, say, why? What's going on there? One of the big challenge we definitely say is that this workforce crisis, especially the skilled workforce shortage, that is already becoming, it's kind of like the Ford CEO called it a national crisis in US. And these two things are correlated. Basically, eventually, the factory's productivity is depending on the quality and the speed of the decision make there. Because in the factory, you need to run, you need to manage all this exceptions, and then this decisions quality and speed is decided by the skilled workforce. So basically, this I would say this traditional human-centric operating making model is not sustainable in today's world. And sure, you know that the increasing supply chain complexity, product complexity, process complexity, if you add all things together, you say, this model just does not work anymore. You cannot sustain this model. You need to figure out something new. And obviously, this is why we are very excited about this hybrid workforce.
Very good. And this shortage of skilled labor is an issue here in Europe as well. And I believe you suggested it's the same in Asia as well as in the United States, as you say. So looking into the future then, well, you just explained how industrial automation has been in the past. Now, are we still going to have like deterministic rule-based automation, or do you see a completely different architecture in our industries?
There's definitely an evolution of the architect. If you think about what we had before, right? Automation, there is hardware automation, this is robots, conveyor lines, AGVs, and there's a software automation, for example, robotic process automation. Like you said, they are deterministic, meaning that they are rigid, basically. Yeah, but for sure, they are reliable. I think the promising of this new technology, especially AI, agentic AI, is that we all know that reasoning AI can reason, it can navigate in the dynamic environment, meaning that this agent workflow can be very adaptive. You can handle all this edge case. So I think it's not like this or not. It's really the end. What we say, when we think about agent system, it really is a compounding system. We will leverage both deterministic tools like workflows, but also leverage this probabilistic engine that's powered by the reasoning AI and the generative AI. That is pretty much. Then you can have both flexibility, adaptability, and also the reliability, right? That's pretty much what we say.
So are agents going to replace humans?
100% no. I don't think so. I think what we say is that agents pretty much like our teammates. They are really good at performing some task on behalf of us and in collaboration with us, but they are not going to replacing people in the factory. We are still, I mean, we are still too far away from there. But we do say that agent is capable today's technology. Let's say even the world stopping to investing, advancing this large language model, AI models, even today's technology are already capable to do a lot of high level tasks for us and alongside with us. That is where we are.
Okay, so share one or two specific AI agent-based use cases with us, please.
Yeah, sure. I think there are several things we say clearly now. The first one is that you and me and factory workers, I think many of us, I would say most of us, are using some AI tools like ChatGPT, Gemini, or Cloud, right? So we use it to find answers, basically. This is almost a very natural ask from the factory team say, hey, if I can use something like ChatGPT to find answers in my daily life, I want to use something like that.
Yeah, I very much like that point because I think exactly like that. You already mentioned a couple of them, and I happen to use one of them, which happens to be Gemini on a Pixel, but that's not important. And I happen to use it solving not problems, questions, answering questions in my personal life. That's why I jump in. Sorry for that. And I think exactly like you, because I am using it privately, then I come. It's not specific for me, but I can completely understand the person on the shop floor having exactly the same experience and then thinking, oh, why am I not capable at the moment to be asking the questions that I need to be answered while on the shop floor, right?
Exactly, exactly. Now, as in the past, especially I would say in the past 12 months, we are starting to see this advancement of this AI capability. People call it agent. So basically, it's pretty common that more and more people, for example, using AI to do some research, right? So it's marketing research, and more and more people are using AI to do the coding. That's is really powerful, and our team are using AI for every aspect of our software engineer. And then now people say, hey, if I can use AI to do some research and guide me to fix my refrigerator or dishwasher, why cannot I use these capabilities in fixing my machine, right? In the factories. Or people say, if I now can use AI to do a scheduled job every morning, read these newspapers, this website, and give me a summary of what happened yesterday, what's happening today, so I can make a better investment in my stock portfolio. Why cannot I do it in my factory operations if I was a plant manager?
So why didn't we have them until now? Has it been that difficult, that hard to scale, to introduce, to deploy agents in the factories?
I think 100% because difficulty, and also if you think about the big challenge to bring in this daily life use case into the factories, well, by the way, the use case that's mentioned, right? Find the information, troubleshooting my machine, give me operation report, help me monitor my quality process. That's exactly top use case we see again and again in the factories now. But the challenge to bring them into the factories, there are three big challenges. One is obviously the trustworthiness and reliability. Now, we can go on that topic, talk about hallucination, talk about the nature of AI models, the why is hard. But the fundamental big problem there is that the AI know nothing about your factories. If you are in certain factories, AI need to know your factory, connect with your factory data to get some good answer to you, right? That's a big part. And then the second part is that talking about agent, you need to take some actions, right? You say, hey, I'm repairing this machine and I know that I need to replace this spare part. In the ideal world, AI should go there, just order a spare part if you don't have anything in the inventories. That is taking action part, need to integrate AI with your own factory system, right? The IT and OT system out there. And the third thing is that when this AI system is becoming more complex, the context is really critical because AI is basically predicts the next token by nature based on the context you give it, right? The better your context, then the better output you get, better quality you get from there. So anyway, all this challenge from the technology side, right? get your access to your knowledge, get access to your system so they can interact with your environment, and then organizing this contact. These are all these technology challenges you have to overcome.
When I wrote in your paper, you just mentioned as well, you talk of a snowflake nature of each factory. Now, as it is snowing around you and it's snowing around me, what exactly do you mean by the snowflake nature of factories?
Yeah, I think it's pretty much think about this way, right? Factory is complex and different company, they have different process. Even the same company, different plant, they operate different way. Even in the same plant, they have the different machines, and that if in the same company, same factory, same line, same machine, they are running on different product by different people. So because of that nature of the complexity, meaning that almost every problem there is a snowflake.
So I see millions of snowflakes when I look out of my window here, and
100%.
although maybe I think, well, I think they change from being smaller to bigger over time. But although I may think that they're all the same, they're all different. That is what you're suggesting, and each factory is different.
Each factory is different, and even in the same complete same siting, different times different, right? The problem you are solving today is very, very different than the problem you are solving maybe 3 months ago. That is the nature of the factory. And by the way, back to this automation concept we talked earlier today, that is why this human-centric decision making does not work. This is why the rigid legacy technology, this reliable but rigid automation does not work because you cannot scale in that environment, right?
Right. Now, one other challenge I saw you suggesting was the lack of empowerment of frontline teams. You want to talk of that one, and then maybe at the same time or just after that, talk about how to overcome this and the other challenges that you mentioned?
Yeah, sure. Well, this is really about the operating model. If you think about the way people think about the factories, well, there's different leadership styles in different companies. But what we observed is that the factories which had a servant type leadership and also the people who empower the frontline team really can have some magic things happen. I was in this tire building factory several weeks ago, and I'm not telling the details, but I can tell you that that team, that factory is a great example that how they empower the frontline team, they trust the frontline team to make the decisions when and where that there is problems. And that is one of the, to be honest, that's cleanest, best organized factory I ever seen in my whole career. I've been in maybe 200 factories altogether or stuff there. So what I mean by this frontline empowerment is that it's more about you have to trust the frontline team to make decision. You cannot just say, hey, anything you change there, you have to go through all this process because factory is so dynamic. And that model just did not work well. And more importantly, people say, hey, one of the reasons we cannot trust many of the frontline teams making decision is that they don't have the knowledge, they don't have the expertise to make that decision. But now think about this. We talk about this generative AI and agentic AI. This AI are really, really good at to find answers, to empower people to make better decisions. Eventually, each of the factory team workers, they can have a super smart teammates or super big brain, a system to make decision. In that scenario, almost a traditional culture say anything you change there come through this approval process. You need permission to do that. That's a conflict with this empowerment for the frontline team with new technologies. That's pretty much, I mean, culturally, I say that can be a big barrier for us to overcome to adopt industry agent.
Right. So, how to then overcome these challenges?
Yeah, I think we definitely need some governance model there. That's still needed. And we need culture shift. This we talk about this servant leadership style. And from the technology adoption side, I do feel that we need to start think about a very different technology adoption pattern. So I was from the MES ERP world, as I mentioned. Almost all this technology adoption is top down. You go there, you say, hey, we are going to do the ERP MES, management team likes it, and they say, hey, there's a lot of value, let's do it. Then you go to the frontline team, they say, we are going to do it, but what's in it for me, right? I'm doing MES. It just require me to collecting the data. So in that approach, the top-down works. But now we talk about this AI and agent, as we just mentioned, right? People say, hey, I'm using AI in my daily life. I'm going to use AI in my daily job. I want to use it. I see a lot of value. There's never short of excitement from the frontline. And as we know, there's never short of innovation from frontline team either. So what we say that the different adoption pattern is that you almost have to have a top-down planning, governance model, and meanwhile, don't stop there to give certain freedom to your frontline team, allow them to explore it, allow them to innovate in the frontline team, in the front line to use it. And then you can take some best practice, you can roll out to broader organizations from there. It's kind of like a very agile top-down plus bottom-up adoption approach. We say this can be much needed, I would say. It's almost necessary in this new world.
Right. In your paper, you talk about so-called scaffolding capabilities. Can you explain what they are?
Yeah, 100%. So think about this. AI system is a system, right? Software system. It's pretty much like a computer. Think about it as a computer, right? And AI model is more like the CPU running our computer. But make this computer work for you and me, to make this computer, you need to surround this CPU with all these different capabilities, building blocks, this I/O, right? The input, output, the keyboard, the screen. You need memory, right? And you need the hard disk, and you need these perpetuals, how to connect with the other system like a USB, all this stuff. These surrounding building blocks are really the scaffolding we are talking here. This is really critical for AI, especially this generative AI model and reasoning AI model, because by nature, they are I call it static intelligence, meaning that the cut off the training maybe is last December, then the AI only know the knowledge trained by end of December, right? That's a static intelligence. And number two, the AI only have access to the public knowledge, don't have any access to your private knowledge. You need to connect it with your private knowledge and also connect with your environment. And number three, AI has very short memory. That's people call it context, right? So basically that's a short memory problem. Anyway, so make this AI work, make AI trustworthy, reliable, then you need all these scaffoldings. It's pretty much software engineer.
So, how are we then going to attain complete accuracy? I mean, how are we going to exclude the hallucinations of the LLMs? So, the agents, is that what your scaffolding also is about, building it around the LLM?
That's exactly what the scaffolding will do. Think about LLM, right? LLM is probabilistic engine, as we mentioned, and LLM has a short memory, as we discussed, and LLM is a static intelligence, and LLM needed this way to interact with the environment in the factories. So this scaffoldings is more about to improve the reliability, accuracy, and consistency of the AI model. I mean, we can go deep, even a little bit deeper there layer is if you think about what are the hallucinations, there can be a factual hallucination, meaning that AI don't know, they don't know, they make up some fact in a very professional way, by the way. It was confusing, right? And it can be AI can have some procedural knowledge, meaning that you use AI to do a 10-step work, but each step AI maybe have only a 95% success rate. And after 10 steps, then that's becoming a disaster. You don't want that. So that's why you need some deterministic guardrails, workflows right there. And then obviously you need to organize the context. As we mentioned, AI model is nothing but predict the next token based on the context you gave to the AI. So the quality of the context decide the accuracy of the AI agent output. So then you need to organize that context for the AI on the fly. That's what people call context engineering. So all this together, I mean, almost the majority of the scaffoldings to ensure the trustworthiness and accuracy. And for sure, this AI is your teammates, right? This AI need to collaborate with human team. That this human agent interface are also a big component there. Integration with environment, the big component there. Yeah, that's pretty much the scaffolding. But definitely ensure the accuracy and consistency is the biggest reason for this.
Right. So now I'm very much interested in how your technology stack looks like. So as you've been co-writing the article with Amol from Microsoft, we may assume that your technology stack is Microsoft based. Nevertheless, just let us know what it is and if there's any domain specifics from your own company on top of that.
Sure. If you think about our partnership with Microsoft, right? Microsoft is infrastructure layer, and they have the best computing infrastructure. They have this AI foundry where you can have access to almost all of this best AI model in the world. And they have the great security infrastructure as well, right? Vendor security. And they have a great data platform, something like Fabric, Azure Databricks, all that stuff there. And obviously, they have some capabilities on the IoT as well. But for the companies, say, hey, I need to use AI agent in my factory, then they still need almost kind of custom build it, right? Custom build this agent scaffoldings. Another big part is this industrial context graph. Basically, it's about knowledge about your factory. That's a foundation piece as well. And if you think about these two layers, is software engineer basically. And what we say is that okay, we talk about factory is a snowflake, and building one even simple agent, even a chatbot, to be honest, take the company 3 months. And one factory can need eventually run maybe tens of agents, hundreds of agents. And now you think about the production network with 50 factories, we are talking about tens of thousands of agents. Obviously, this custom build model is not sustainable, scalable either. So we say, okay, there are some common building blocks as we mentioned, we talked here. We know that has to be tailored for the factories. For example, you need to connect this system with your factory knowledge and turn them into knowledge graph. And you need to connect with the IT and OT system, turn their API and function calls into some tools which can be reliably used and reasoned by the AI model. And you need to orchestrate the usage of different AI models to optimize the cost and the performance. You need marry the AI the reasoning capability with workflow. Basically, that is deterministic guardrails for the AI workflow. On and on, right? So we say, okay, these are common needs. We just build these common needs for the factory scenario into some pre-built building blocks on top of a Microsoft infrastructure. The benefit for the company is that before, whenever they need a new agent, it takes them maybe 3 months, as I mentioned. Now they can do it in just several hours. And before, the manufacturing company, large company, they may have a dedicated AI engineering team of 3 or 2 people. Before, they can only support maybe one factory, 2 projects per year. Now suddenly they have almost like 200 engineers. They can support the whole production network. That's pretty much what we do. You can say us as a vertical agent platform running on top of Microsoft horizontal infrastructure.
Right. So you are a Microsoft partner. Now, what is it that you provide, so to say, in addition to your customer working, maybe already or not yet with Microsoft? What is it that you provide on top as your specific manufacturing operations solution?
So on top of our solution, what we provide, we talk about this scaffolding, and we talk about this context engine and knowledge graph. And then on top of that layer, we also work with our partner and customer to turn, we call this common use case. We talk about this finding answer use case. I call the factory ChatGPT. We talk about these capabilities like machine troubleshooting, quality root cause analysis, operations report, all these use case. We turn this common use case into some pre-built agent, meaning that the industry best practice are already embedded, the data model already embedded, the connector is already embedded, and then when the new factory will need to use it, all they need to do is pretty much like say, hey, let me hook your agent with my environment, with my knowledge, and then this agent can plug and play. That's pretty much the concept we are having here. But obviously, in the real world, every company has different system. You still need to do some kind of like fine tuning along the way. But still, I mean, we say 80-90% reduction on the time to value. That's pretty much what we are.
Right. So why should your potential customer consider working with you, buying your solution rather than building their own solution?
I think that is pretty much eventually about the time to value. It's also about the TCO, right? Again, give you one example. One company we are talking now is that they are talking about building 6 agent, and they have 2 AI engineering, and the business team see a lot of value on each of these use case, but they are not waiting for 3 years to get this value, right? And we talk with electronic manufacturing company. The company basically say, the CIO basically told me that this is an operational advantage. We competed with this basically another big competitor for them, and she basically said that we need to move faster than that company. There's a lot of reasons why time to value, competitive advantage. This pretty much all these reasons. And eventually, also another big part I would say is that for many of these less advanced companies, I mean, we work with a lot of these industry leading pioneers companies, but for a lot of other companies, I would say they are sitting there and they heard all this marketing hype, and they say, hey, this all sounds good, but what we can do, and can we really deliver it? That is what they want, right? They want to validate it. They want some kind of like reference, say what they can do, and then validate it quickly. That's kind of like another a reason why people work with us, because people say, hey, you have a lot of experience there. Well, we're early stage. I'm not saying we have a lot of experience, but we are an early pioneer there. They say, hey, just work with us and figure out what we can do with the technology, and then we can quickly prove it that it's good.
Right. So what do they need to deliver? How about the data quality or the data readiness of your potential, or at that time when they become your customer?
Yeah, I think that is another topic. I would say is really a different paradigm. And the short answer is that you do not need perfect data to start this agent. And instead of thinking them as a static, rigid code or software program, we should think about this AI agent, something really like humans, right? So let's say if human, you and me do not need a perfect decision, perfect data to get some insight, make some decision, then in certain degree, this AI agent do not need a perfect data either. That's the first difference I would say there, because by nature, this AI has some common sense reasoning capabilities. They're really good at processing the unstructured data, all that's written there. Anyway, that does not mean that this data foundation is not important. You still need, right, continuously build this data foundation, but you do not need to wait 3 years to have perfect data foundation. By the way, you will never have perfect data foundation.
Yeah. There's nothing wrong with perfect data, but if it's not yet perfect, that's okay. Is that what you're suggesting?
Exactly. Yes.
And nevertheless, I understand that you provide kind of the service to organize data and knowledge in a knowledge graph. Can you talk about that? The need for the knowledge graph, is that then about, again, let's say, quality of data to make it easier for an agent to get into such a knowledge graph and then to extract maybe higher quality information, or to be able to provide higher quality answers?
Yes, 100%. Yeah, I think let me use an analogy there, right? Firstly, this is less about data, but more about knowledge. Here's what I mean. Imagine that your AI model, pretty much, today's AI model, you may saw some benchmarking data, basically say they are better at world-class team in the math, coding, all stuff there. Imagine that the AI model is more like you hire a super smart genius from MIT or the best university in Germany, for example. But this super genius engineer student know nothing about your factories, right? To turn him or her or them into one of your best engineer in the factories, basically you need to give them access to your IT OT system. You teach that what are there in the system. This is something we call it meta knowledge, this knowledge about your IT and OT system. You also need to teach them, say, if you want to learn more about this machine, we have a library of this machine. There's a vendor manuals, there's drawings, there's repair record, all stuff there. You should read that record, refer to that record. This is we call explicit knowledge. And then you will give them a mentor. Basically, say this mentor know this area so well, and this mentor can teach you some tribal knowledge or tacit knowledge. And then the last one is that there's always some policies, the guidance, the procedures this new worker, new engineer need to follow. That's we call it procedural knowledge. So and then there's a context. The context is that in this factory we have 20 lines. On this line we have 5 machines, blah blah blah. Oh, by the way, in this factory we have 120 people. This is who they are, what they do. Anyway, this now we're talking about you have 4 types of knowledge. This is tacit knowledge, procedural knowledge, the documented explicit knowledge, the meta knowledge, and this planned context. To make this AI work, just like make a new employee work, you need to connect all the dots for them into a memory. That's pretty much what we call knowledge graph. That's what we do. We have this industrial context engine. We use AI agent basically to build a memory for the some people call it factory brain for the customers. That's about knowledge.
Okay, James, thank you very much for your perspective, your view on how to introduce agents in the factory. Now, before we close off, maybe you want to tell us a little bit more about, you already suggested you are in the Boston area, I believe, but tell us a little bit about your team, who you are, who maybe your colleagues are, maybe you're looking for talent. If so, what kind of capabilities should they bring?
Yes, thank you very much for that, Peter. And our company is headquartered in Boston. And the founding team, myself and Howard Hepman, who is our CEO and also a colleague at SAP, at PTC, and also the other founding members and the senior team are from PTC and from my time at SAP. So, long story short, we are working really in this frontier area. I would say this intersection of the factory manufacturing and also this general AI, agentic AI, reasoning AI. So what we are really looking for is that solving some hard problem there, and we are definitely are would like to hear to the people who are interested in solve this hard problem, who share the same mission, especially from the engineering side. Although it's always open. I mean, to be honest, we there's there is a very few people are working on this area now, and we would like to connect with anyone and everyone who is working in this area now.
Okay, dear listeners, if you're interested to be working with James and his colleagues, we'll make sure that you get the information in our podcast notes. James, thank you very much and have a great day.
Thank you. Thank you, Peter. Really enjoyed talking with you. Have a good one.
Thanks. Bye-bye.